Hi, my name is Sarah, and I am a graduate student at UCSF. I study a fungus named Histoplasma that can cause severe disease, both in immunocompromised people as well as in healthy individuals. Today, I'm going to talk to you about a very new discovery that sometimes this pathogen makes extra DNA. This extra DNA can change the shape of the pathogen in a way that affects infectiousness. Fungi exhibit diverse morphologies and physiologies. For example, some fungi grow as mold, as you might see, for example, in blue cheese. Mold looks a bit stringy under a microscope. Some fungi grow as yeast, as you might see in a sourdough starter, for example, which looks a bit like this under a microscope. And some fungi grow as mushrooms. Some fungi, however, can exhibit multiple morphologies or shapes. The ability to grow in multiple morphologies is critical to pathogenesis of thermally dimorphic human fungal pathogens, such as Histoplasma. Histoplasma and other thermally dimorphic human fungal pathogens grow as hyphae or mold at ambient temperatures. This mold can be aerosolized and inhaled by mammals. If inhaled, it responds to body temperature by transitioning to growth as a pathogenic yeast. I'm interested in this morphology transition as it's essential to the pathogenesis of this important class of human pathogens. Based on technological advances, we've recently identified the chromosomes in Histoplasma. There are 7 of them, as shown in rainbow colors in this infographic. However, some strains have extra DNA that we think makes up an additional chromosome, as is shown on the right here. As I said previously, most strains of Histoplasma grow as infectious hyphae at ambient temperatures and as pathogenic yeast at body temperatures. However, some strains are yeast biased. These strains can grow as hyphae under extreme hyphal promoting conditions, such as prolonged exposure to 25 degrees Celsius, but generally grow as yeast. In multiple yeast biased strains, we found that this extra chromosome reverts the strain to wild-type behavior. By some assays, the extra chromosome even encourages hyphal growth beyond what is seen in wild-type strains. In other words, the extra DNA is associated with hyphal growth and thus possibly with infectivity. We've seen evidence of this DNA in some clinical isolates of Histoplasma, indicating that it may be relevant in nature. Additionally, we've been able to compare strains with and without this extra DNA to help tease apart the genetic regulation of the infectious form of this fungi. We hope that this information may be relevant to future development of treatments or prophylaxis for this important class of human fungal pathogens. Thank you for listening, and thank you so much to ARCS for helping to fund this research.